Number 189 in class check for polynomial functions asks you to name the real and complex zeros and state their multiplicity. So here we have a cubic function, 2x cubed plus 3x squared minus 8x minus 12. And sadly, we're going to have to go about this by factoring it using the rational roots theorem and then synthetic division, probably the fastest way. So we're going to go ahead and find the real roots. So we know the possible combinations could be all the factors of negative 12 divided by the factors of 2. So we can have plus or minus 1, plus or minus 2, 3, 4, 6, and 12 over plus or minus 1 and plus or minus 2. And so our real roots come out to be all these ones in the numerator divided by plus or minus 1. So that's just written them over again. And we also know that they can be over 2. So we have more. We have plus or minus 1/2, plus or minus 1. We already covered that one here, so I'm going to leave it out. Then we can have plus or minus 3/2, plus or minus 4 over 2 is 2. We already covered that one as well, so I'm going to leave it out. We can have plus or minus 6 over plus or minus 2, which is just plus or minus 3. So we also covered that. And the plus or minus 12 over plus or minus 2 is plus or minus 6. So we also covered that one, meaning that we have 1, 2, 3, 4, 5, 6, 7, 8, 16 possible roots. So now it's time to try them all out. And so trying out x equals 2. We're going to use synthetic division, so we have 2, 3, negative 8, and negative 12. We're going to bring down the 2. So 2 times 2 is 4, plus 3 is 7, times 2 is 14, plus or minus 8 is just 6, and then times 2 is 12. We get a remainder of 0, which is key, because that determines if it's a factor or not. So we know that x equals 2, meaning that x equals minus 2 is a factor of the original polynomial. So we can rewrite this as x minus 2, and we're left with this quadratic. So we have 2x squared plus 7x plus 6 as our leftover piece that we also want to factor. And so we're going to do this probably just visually. So we want to have something that multiplies to this a times c, which is 12, but adds to 7. So we can do that with 3 and 4. So we can have, we can break this 7x up into 4x and 3x, and go ahead and factor this. So we have 2x times x plus 2 plus 3 times x plus 2. Meaning that we have 2 more factors of 2x plus 3 times x plus 2. And so we can write these over here. So this is our fully factored form of the polynomial. And now, so this is very good. We know that all of these factors are raised to the power of 1, so all their multiplicities are 1. And they all appear to be real, so we can just set them to 0. So we'll have zeros at x equals 2, at x equals negative 2, and at x equals negative 3 over 2.